Autotrophs need nutrients like carbohydrates, proteins, lipids, and vitamins for their metabolism, growth, and reproduction. What distinguishes autotrophs from heterotrophs is that they can make these organic compounds through the process of photosynthesis, whereas heterotrophs must get them from eating other organisms. In photosynthesis, plants absorb elements from their surroundings, carbon dioxide and water, and they convert this into glucose, which is a source of energy for autotrophs. And much of this glucose is not needed immediately by the plant for generating energy. Some of the excess glucose is stored as starch, but other proportions of the excess glucose are converted into other nutrients needed by the plant, which include carbohydrates. For example, sucrose and cellulose are both carbohydrates made from glucose. There's also amino acids, which are used to form proteins, which are important as enzymes for plants. It's also made into chlorophyll, which is a vital pigment for photosynthesis, lipids, and vitamins. The elements that plants absorb in order to construct these organic molecules are called essential nutrients. And there are at least 16 elements essential to all plants. 9 of these are macronutrients, which means they're needed in large amounts. And these are carbon, oxygen, hydrogen, nitrogen, potassium, calcium, magnesium, phosphorus, and sulfur. Now, carbon, oxygen, and hydrogen, as you can see from this pie graph here, are the most abundant and the most important macronutrients for plants, as they make up 96% of the dry weight of plants. Plants also require micronutrients, which are nutrients they need in smaller amounts, such as chlorine, iron, boron, zinc, manganese, copper, and molybdenum. Plants obtain carbon, hydrogen, and oxygen from water and the atmosphere. Water enters the plant through the roots. Carbon and oxygen come from the atmosphere in the form of carbon dioxide. And that gas diffuses into the leaf or stem of the plant through pores called stomata. As roots absorb water, they also take up all the other essential elements. And these nutrients are dissolved in the soil's water when rock particles weather or when microbes decompose dead organisms. Plants often get help in obtaining water and nutrients from organisms in the soil. So, for example, the roots of most plants are colonized with fungi. The plants have a symbiotic relationship with this fungi. The plants provide carbohydrates to the fungi, and the fungi has filaments that spread out and absorb water and minerals that plant roots would not be able to reach. So you can see those. Here is the root of a plant, and coming off that root, you can see all these fine filaments, which are effectively just extending the root system of the plant itself. In particular, phosphorus is poorly soluble in water and does not move easily across the roots of plants. So the fungi increase the absorption of phosphorus by plants. Nitrogen gas makes up about 78% of the atmosphere, and it's essential for plants to synthesize nucleic acids for building proteins. It's also really important for building chlorophyll. However, plants cannot absorb nitrogen gas directly from the atmosphere. Instead, roots must take up nitrogen from the soil in the form of nitrates, which are represented as NO3 minus, or ammonium, which is NH4 plus. Now, these ions can be very scarce in the soil, which can restrict the growth of plants. Fortunately for plants and animals in the long run, there's actually several different types of bacteria in the soil and living on the roots of plants that can convert nitrogen gas into ammonium. And this process is referred to as nitrogen fixation. This is really common in legumes, so things like peas, for example, or clover. If you were to pull clover out of the ground and look at the roots, you would find these nodules. And inside the nodules, there are bacteria which can convert nitrogen into ammonium, which is a source of nitrogen that the plants can use. You could also look at the root hairs, and inside the root hairs you can also find nitrogen fixing bacteria. Nitrogen fixing bacteria are particularly important in Australia due to our poor soils.